Hello everyone. Today we will extend our previous discussion about Git basics. Today we will delve a bit more deeper inside the workings of Git. How does Git work internally and how does Git is able to leverage or how is Git able to provide so much advantage over other version control systems. So let's get started. We will be looking at a short history of Git. How did Git come into existence? We will also look into how does Git store the various files inside it, and we will complete our discussion with a small demo of what we discuss theoretically. A history of Git goes like this. Git has its origin in Linux kernel project. Linux kernel project, as you might have already knowing, that it is one of the milestones in computer software development industry, and it has a fairly huge code base. So initially the changes of the code base were passed around as patches and archived. So whatever the changes used to take place, a patch set of them used to be created and saved, and those patch sets were utilized to recreate any particular version of the code base. As you might have already understood that this is definitely not the most efficient way of doing things. So the team resorted to using a certain version control, and that version control's name was BitKeeper. So they were using it and it was doing their job, but after a certain point of time, the contract or the relationship between the two parties, the community that developed the Linux kernel and the company who developed BitKeeper, broke down, and this led to the Linux team create a version control of their own. Particularly, Linus Torvalds was a factor inside behind the creation of this version control. So in order to create the new version control, they wanted the advantage which BitKeeper used to provide them. They wanted to use the lessons which they learned while using BitKeeper. So there were a lot of advantages which BitKeeper used to provide, and they wanted to have the new system also to have those advantages. So let's look at what those advantages were. The advantages were speed, simple design, strong support for non-linear development. It used to support thousands of parallel branches. It was fully distributed and it was able to handle large projects like the Linux kernel efficiently. So these were the uh, design uh, thought process which the team wanted the new version control to have. Now, when they accommodated all those design philosophies, so they came up with a version control named Git. And the way Git was designed internally has a pragmatic shift from other version control systems. So it has a major shift in the way changes are stored. So the comparison is listed here or is depicted here in two pictures. So the top picture shows the way changes are stored in other version control systems, and below picture shows the way Git stores the changes. So in other version control systems, the changes are stored as deltas. So if you see in the top picture, there are few versions listed here: version 1, version 2, version 3, version 4, and version 5. So let's say initially the files look like file A, file B, and file C. Okay. And in version 2, file A had some changes and file C had certain changes. Okay. So in version 2, what is stored is the delta what is created for the files. So file A has a certain change, file C has a certain change. Okay. So the delta of these two files are stored in version 2. If file B has no change, nothing is stored for this file B in the version 2. Okay. So every version has the delta which is created over the previous version. Okay. So in version 3, the delta, the file C has changed, but file B and file B A has not changed. So version 3 only contains the delta for file C, what has changed over the previous version. Okay. So similarly, version 4 has certain change. File A has certain change and file B has certain change. So the deltas for these two are saved inside version 4, but nothing is stored for file C. And similarly for version 5, the delta for file B and file C are stored because these two files are having changes, but there is no change having is there for file A. So nothing is stored for file A. So every version has nothing but the delta of the files who are changed. Okay, and these deltas are actually used to recreate any particular version. Okay, so if you see theoretically, conceptually, the most other systems store information as a list of file based changes. These other systems like CVS, Subversion, and Perforce think of the information they store as a set of files and the changes made to each file over time. This is commonly described as delta based version control. So everything is the delta of the files. Okay. So, but with Git, it has got a major shift. It doesn't store the changes like this. So what it does is, it essentially what it does is with Git, every time you commit or save the state of your project, Git basically takes a picture of what all your files look like at that moment and stores a reference to that snapshot. To be efficient, if the files have not changed, Git doesn't store the file again, just a link to the previous identical file it has already stored. Okay, Git thinks about its data more like a stream of snapshots. So let's say in if you look at the below picture which depicts Git's way of storing changes. So this in the version 1, it looked like the file's state was file A, file B, and file C. Let's say this is the initial state. Now in version 2, what has happened is file A has changed to a certain state, okay, and file C has also changed, okay. So but in file B has no change, okay. So now in version 2 what is stored is the entire snapshot of the file A itself. So it is not like that it stores from the delta from the previous state, but the entire snapshot of the file, what it looked like at this state is stored. And similarly for file C also, the entire snapshot of the file C, the way it looks like at this point of time is stored. For file B, since there is no change, a pointer to the previous state is stored. It is just a pointer. In version 3, file A and file B are not changed. Okay, so you can see it is written A1. A1 means the pointer to the previous created snapshot. So A1. So it is basically a pointer to the previous one. Similarly for B, no change. So a pointer to the previous state. B, which is basically again the pointer to the initial state. So it is just a pointer to the previous state. File C has changed to C2. So the snapshot of the C2 is stored. So the entire snapshot, whatever is there at this point of time is stored. Okay, and similarly for version 4 and version 5. Okay, so continuously the different versions store the entire snapshot of the file the way it looks like at that point of time. So this basically is fundamental to the ways Git works, and we will look at it at a later point of time that how Git uses this kind of architecture for the advantage which it has over other kinds of version control systems. Okay, so let's move ahead. So in Git, nearly every operation is local. Okay, so if you want to look at a history of Git, you do not need to connect to the server. So as we had discussed earlier, that a client machine, when it clones the repository from the central server, it gets everything whatever is stored on the server. The client machine also has it. Okay, it has got all the history, it has got all the branches. Okay, so when someone wants to look at the history, he or she basically can fire a command, and that command will fire on his local machine, and he or she can get the history instantaneously on his machine, even if he or she is not connected to the central server. Okay, similarly, switching to a branch is also a local operation. Okay, so since that local machine or the client machine has all the branches, okay, so the developer can quickly move to a branch, and he or she doesn't need to connect to the central server. This is unlike other version control systems like SVN. When you want to switch to a particular branch, you actually need to connect to the central server, because the central server is the place where the information about the branches and the contents of it is stored. Okay, and the client machine has to connect to that central server to get that. But in case of Git, everything is on your local machine, and you do not need to connect to the central server to switch to a branch. Likewise, committing as well is also a local operation. You make changes, you commit it, that commit is created on your local machine, and your history becomes clean again, so that you can continue on other tasks. But if you want to push that change to the server, you need to connect to the server. This is the only operation where you need to connect to the central server. Other than that, almost all the operations inside Git is local. Okay, and because of this nature of Git, it makes it incredibly fast. You can work, you can create a branch, you can make changes, commit to it, switch to a different branch, work on another feature. All of these things you can do even when you are actually traveling on a traveling, whether on a plane, train, whatever. So even if you are traveling and if you have some time to work on, you can go ahead and make changes and commit it. Okay, which is not the case with other version control systems. Okay, so let's look at the workflow of Git. How does Git work? So in Git, essentially there are three states: the working tree, the staging tree, and the Git directory. Okay. So what happens is, initially from the Git directory or the repository, the developer checks out the project. When he or she checks out the project, it becomes his or hers working directory. Okay. This is where someone works on and modifies the files. Then he or she stages the files he or she intends to move into the next commit. He stages those changes into the staging area, and then he or she commits things. So these are the three states which Git has. The working tree is a single checkout of one version of the project. These files are pulled out of the compressed database in the Git directory and placed on disk for you to use or modify. So this is the Git is the working directory. Okay. The staging area is a file generally contained in your Git directory that stores information what will go into your next commit. Okay, its name, technical name in Git parlance is the index, but the phrase staging area works just as well. Okay, whether you call it a staging area or the index, that means one and the same thing. Okay, and the Git directory is where Git stores the metadata and object database for your project. This is the most important part of Git, and it is what is copied when you clone a repository from another computer. So when you clone a project, so this is the Git directory which is created on your machine. Okay. So essentially this slide also mentions the same thing. You modify files in your working tree, okay, and then you selectively stage only those changes which you want to be a part of your next commit. Okay, and let's say if you modified 10 files, but you only want to commit only 8 files, Git does give this facility that you can only choose only the files which you want to move into the next commit. So let's say you want to select only 8 files out of 10, you can go ahead and stage only 8 files and leave the 2 files behind. Okay, when you commit it, those files are the files which are there in your staging area. Okay, so what Git does, it stores the snapshot. Okay, so as I said earlier, that whatever the files which you stage, it basically takes a snapshot of it, the exact snapshot, not the delta, but the entire snapshot of the files, and stores them permanently into your Git directory. Okay. So that is how the Git workflow looks like. Let's look at a demo of the things which we have discussed till now. Okay. So in order to work on Git, so what you need is a Git repository. Okay. And you need a Git installation on your machine. Okay. So, so when you install Git, so you will get a Git bash. Okay. You can go ahead and download Git from the official website and you can install it. When you install it, you get a Git bash from where you can fire your commands. Okay. So for this demo, what the repository which I have chosen is this one. So this is the repository which I have created on GitHub. Okay, github.com. This is the repository which I have created, and what I have done is I have basically created a few branches here. There is one default branch master, and I have also created two feature branches. Let's say these are the feature branches. Okay, so essentially the name should not be like this, but let's say for this demo I have created the name like this, but in actually things you should have a proper nomenclature which reflects the issue or the bug or the story which you are working on. The branch should reflect that. Okay, and that is the way we work. Okay, so to start off, what we will do is I'll clone this project. Okay, so this repository in my local machine. So how do I do it? So when you go onto the repository, on the when you where the button you see written code, you can click here. You will get one URL using which the URL this is the URL of the repository. You just copy it. You go to the git bash, and the command which is required is git clone and paste. Okay, so I'm doing this. So you see it says cloning into medical shop. So uh, you see it's doing something. It will show you the uh, how much it has been done. Okay, now you see it's 100% done. So it has been cloned on the local machine. So where I have cloned into this directory. Okay, so I'll go here. So actually I cloned here. Okay, you see, so this is where I have cloned it. Okay, I'll see what is the content of the files. Okay, so when I see here cd, so when I do this, you see by default we are in the master branch. Okay, by default I am in the master branch. Okay, so this branch is uh, created here. Okay, I mean this branch, this master was actually there on the central repository, but when I cloned I also got this uh, branch on my local machine, and by default my repository is into this branch. Okay, so let me see what else do I have. Okay, but before that let me uh, clear it. Okay, so when I see git branch, okay, so it just shows that I have master branch. Okay, so at this moment of time, okay, uh, locally, okay, I have the master branch. Okay, but when you do this git branch hyphen r, okay, so what it does is it also, if you want to see what are the remote repositories, you can see this. Okay, so uh, so origin test branch to origin slash master, it gives you all the branches which is there. Okay, so essentially this branches exist on the remote. Okay, and this branch also exists on the local. Okay, but since you have not checked out this, okay, so mm, Okay, so what you have got is uh, so whatever is there on the server, you have got everything on the local as well. Although it is mentioned as origin slash test branch, origin being the remote which is basically your local machine is tied to. So it's mentioned as that these are the branches which exist, but in on your origin server, okay. But in fact, what has happened is all these branches have been downloaded on your local machine as well. Okay, it is just that it's mentioned like origin slash test branch, origin slash test branch one, and of course origin slash master. Okay, so if you want to work on this any of these branches, you can simply go ahead and check out. Okay, you can go ahead and check out, get check out origin slash or maybe something like test branch directly. You can go ahead test branch one. Okay, so see what is written is you have instantaneously been switched to test branch 1. It's saying branch test branch 1 set up to track origin slash test branch 1. Okay. So, so whatever was there on your server got downloaded on your local machine, and you can start working on that server, on that branch, by simply going ahead and checking out that branch. Okay. So, so now this branch is basically more or less the same as the this branch. Okay, so you got all the branches, whatever on the on your local on your server, you got all of them on your local machine as well, uh, mm, as well when you clone this the repository. And let's see what else did we get when we cloned the uh, repository. So let's see what else did we get. So let's see on the server what things are present. Okay, so here on the master, okay, you see there are three commits. Okay, okay, so let's see what are those three commits. Okay, so you see there initial commit which was done on Jan 10 2016, then they created a readme, then there is another commit called updated readme. Let's see if they are also present on a local machine as well or not. Okay, so when I do git log, okay, okay, you see you also see initial commit, create readme, and update readme. These are the commits. So whatever is present on your server is also present on your local machine as well. You can easily look at what happened in these commits, and there are various commands to it which we will be looking at it in subsequent videos. But what I'm trying to emphasize is, in order to look at history and in order to peep into the history, you do not need a connection to the server, because everything is now available on your local machine as well. Your local machine is now as good as the server machine, okay, till the time someone doesn't push any other thing on the central server, in which case you will have to pull that to sync your local machine with the server. But apart from that, your machine has everything which the central server has. Okay, the next thing is, how do we go ahead and make changes? Okay, so let's say we go ahead and we make a certain change. So let's say we come here and I go here and so let's say this is global dot, or let's say base view model is there, or I've not opened Visual Studio, but uh, we can do these things without in order to showcase what Git is able to do without actually going ahead and opening the solution. So let's say I went ahead, I I make some changes, comment, okay, okay, Control S, I made this change, then I go ahead and I open this file, open with Notepad, and I make one more comment, okay, okay. So now how do I do it? So let's say I go here and I say git GUI. So there are commands to it, but let's show it in a more figurative way. So you see your uh, uh, solution shows So now you see here, you see that the two files are changed. So this is your working directory, okay, and here there are two changes which have been made, okay. So I made a comment in bootstrapper.cs file. I also made a change in base model file, okay. But due to certain reason, I want only one of these change to be to go ahead in the commit. So what I will do is I'll go ahead and stage only this file, okay. So I will stage only this file because I only want this file to go into the next commit, whereas I have left this file as it is and not moved into the staging area. So what I will do is I will uh, make a comment here, okay. So again, this shouldn't be the way we should be committing it, but just for the sake of demo and for the sake of time, I'm not sticking to any no, any kind of guideline. But in the real scenario, there should be a proper way you have to add the commits. Okay, so I go ahead and do a commit. Okay, so mhm. Okay, so what I did is I went ahead and added the username to the how I did it. I'll show you. What I did was I essentially went ahead and added this git config global. Actually, the git wants the username identity in order to be able to commit. Okay, so I just ran this command. Okay, and I set the username. Okay, so after doing this, I think I should be able to commit. So I'm trying to commit it. Okay, uh, committer identity unknown. Please tell me who you are. Run your name. Git config global user.name. Your name. Okay, so it's saying to run both the things, name as well as email. Okay, so let me try to do it. So this one I had done. Let me try to add my email as well. Okay, hopefully I should be able to do it now. Okay, okay, now yes. So after adding both the username as well as email, I am able to commit it. Now, since I have committed it, now you can see if I do a git log, I am able to add this new commit. Okay, so another thing is that in order to commit, I did not need to connect to the server. I just did this operation locally. Now if I want to push it, definitely I need a connection, but till this time I did not need any connection. Okay, so this solidifies our discussion that most of the operation in Git is local. Okay, and why this is so? Because this is Git stores almost all the things which the server has. Okay, and your local repository is as good as the server repository till the time no one else pushes any further change to the server. Okay, so all these things make it incredibly fast and self-sufficient to for the developers to continue working in situations where they do not have connection to the server. Okay, this and along with host of other things makes Git a popular choice amongst thousands of developers. We'll look into other aspects of Git in subsequent videos. Till then, bye bye. Thank you. Take care.